everyone's at least got that URL, whether they've downloaded. Anyone actually downloaded this OVA yet? I'm sure the Wi-Fi can't really take. Oh, nice. 2 minutes, that's good to hear. Next step is actually booting it and making it work, so we'll get to that. Cool. So we just wanted to fill in this slot in the timetable with some content that we've been working on for various things, and this is a bit of our day job. So monitoring consulting, I'm Dave, this is Ollie. We are both from Sol One. We do IT services, consulting, Linux and open source stuff, and have done for a long time. We've come up with a stack of software that helps people, stuff that we've discovered and implemented for our customers. And hey, Matt, you're not too late. We just started. And so we wanted to kind of just walk everyone through that stack, give people a copy of it, see what they think, and hopefully, you get some value out of it for your own data center stuff. So here looks after physical gear in a data center, computer room. Hopefully everyone. So there's cloud guys that can go somewhere else. It's not for them. We can worry about this. To be fair, this doesn't not include cloud virtualization clusters and all that sort of stuff. We'll go through that. But the tools we've got are sort of more suited for real world gear. So everyone grab that URL. You can't connect to it. Oh, that could be a bandwidth issue. I mean, someone else was downloading. So I don't know how many simultaneous sessions that allows. I probably could have stuck it on Google Drive or something like that as well. Anyone actually finished downloading this yet? Or just save the URL. You have to open it in a browser from memory, I think, or put /download at the end if you want to use wget. Cool. All right. All good? Who we are, we covered that. Lab check, as soon as someone actually gets it and see if it works, we'll cover that. These slides were prepared 5 minutes ago, so it's as good as this is. All right, so what is DAING? It's just a silly acronym for some tools that we came up with. The I is probably the most important part. Stands for Icinga or Icinga if you're German, or there's a clicking noise if you're a Zulu. And Director are both components of the same bit of software. We use Ansible to glue things together, Netbox to map our data center information, and Grafana to graph stuff. Anyone used any of these tools before? Excellent. Icinga users? Couple? Grafana, everyone's probably used that. That was where all the hands came from, right? Anyone used Netbox before? Oh, excellent. Excellent, Netbox people. So Netbox is from DigitalOcean. It's a data center information manager, and it basically lets you have sites with racks. Racks have rack units. Servers belong in rack units. They have interfaces. Those interfaces have IP addresses. You can have VLANs, VRFs, all these kind of very useful information, and it's a structured way of documenting things. Icinga is a core monitoring component. It's got its roots in the way Nagios used to work, but it's an entire rewrite because it's Icinga 2. And today what we'll be doing is actually purely web-based configuration. We'll be no command line stuff involved. It'll all just be web UI only because we're using Director. Director is effectively an ETL tool, extract, transform, load, that can talk to APIs like vSphere, AWS, Excel of all things, CSV, LDAP, and Netbox. And we've made so part of the work that we've done, which is actual writing some code in this whole thing, is improve the Netbox to Director importer so that it performs properly and all that sort of stuff. From a performance and scale point of view, the largest site that we're going to be running this on will have 150,000 hosts. And so we've had to massage it to make that work a bit better, but it certainly can scale that big. Anyone got any sites bigger than that they look after? No? Cool. About 1,000 hosts is probably our typical customer, so those guys are quite special. All right, so I'll give you a bit of a walking tour through Netbox. This is very much a live demo because we haven't prepared anything. So, Netbox. Once you get the VM up and running, you'll be able to do what I'm doing here, which is browse to localhost on port 8000 because the OVA includes some port forwards on localhost for that to work. VirtualBox's NAT networking should do the port forwards for you. It just opens the socket and away you go. All right, so this is Netbox. We have added into the virtual machine some sites. A site includes the relevant data that you'd expect. Keeping in mind, the one that we kind of will use for importing things is this idea of a slug, which is a short, useful name. And I'm not going to go through all the data entry, but sites have tenants, and the data model is kind of really important to get your head around because it gets to be kind of painful when you want to add things and it doesn't let you add things. So you have to kind of work your way through the way the data model works. So people go, oh, I just want to add IP addresses. Well, that's not so simple. An IP address has to live on an interface. An interface has to live on a device. That device has to have a valid type, which also has to have a manufacturer. So if you just stumble across a random rack full of gear, it's going to take you a little bit of kind of setup of the data model before you get to the point where you can actually start putting IP addresses into this and doing IP conflict checks and all those kind of things. There are definitely tools that will populate Netbox automatically, and because it has a great API, we can see that there's lots of ways you could write a shell script to push things, or some Python or Nmap, or however you want, if you want to be able to do some automatic things. On the topic of automatic data, the Netbox frequently asked questions is like, why don't you have a probe that scans my network? And I agree with it. It's not the way that Netbox is meant to work. Our opinion of it is that the data in here should be as clean as possible. This is your single source of truth for what is going on in your data center. It should be ideally human validated, with photos. It's got version control. It's got LDAP integration and all those kind of things. Polluting it with random IP address scans is not going to help anyone. And I think that you have a chance here to kind of get some documentation really right about your racks that you probably don't have right now. So I populated some racks in here to give people an idea about how that works. This is the LCA rack 2020. And we can see a rack view. It works with front and back. If I want to add another rack device, I can just simply click on the rack. LCA, mail server 03. Will that work, Ollie? Mail? Yep, cool. It's a server, lowercase m. It's a trick for later. And I've already populated some server types. We'll pick HP because that's the only server I've got. There's some other switches and things like that I've added. If I went to add a server, if I chose, I don't know, a Cisco server here, there's only a Cisco 2650 switch. I don't have an actual server. So that's where you go, oh, I want to add it, and then the next thing you know, you have to go back to the devices and populate all the types that you have. Now, of course, and this is where part of the Ansible thing comes in, we also have playbooks, which I don't think we have time to demonstrate today, which will update this information with Ansible facts. So the important point is that Ansible can read and write from Netbox, read from it as an inventory source, and write to Netbox as a source of truth like collector. So you can connect to a machine and go, hey, here's my interfaces, here's the MAC addresses, here's the IP addresses, all that sort of information. So the steps for that often are kind of like we enter the machine in a semi-manual or through an import process, and then use that as the inventory source, and then connect back to that machine with Ansible using the Netbox dynamic inventory to then enrich the data on each machine. So you end up with a machine with lots of interfaces or MAC addresses and all those kind of things. So anyway, I'll finish adding this server. If you have, you can have, because I clicked on the rack, it just gave me the location and knew what it was doing. You can also have, it supports blade chassis. So you can have a server that has children, and then they go into slots, as opposed to just straight rack units. So that works reasonably well as well. Cool. Everyone keeping up? Yeah? Excellent. All right. So I've added a new server. This is the server view. Netbox also supports secrets. Secrets let you have a JavaScript encoded key where you can save useful secret information. It is accessible from the API. I haven't used it a lot in Anger. I've played with it a little bit. Haven't used it a lot in Anger. We have other ways of storing secrets. Ansible Vault, or we use Bitwarden for our local passwords and various other things. Other customers use their own thing. Haven't convinced anyone to use this in Anger yet. Anyone use the secrets in Netbox? No? But it apparently works reasonably well, and I can see how that would be useful, in particular for things like when it comes to monitoring later, SNMP community names are probably things that you should keep more secret than just sticking them out on the internet. So that's probably a useful one for that, because they kind of don't belong in a password vault either. They're sort of this half secure thing. So anyway, and then services, you can use services as well. Things, and what a service is a port, a TCP port, and then optionally you could use that to create monitoring. We tend not to use that. We tend to use role-based monitoring, and you'll see later when we come to how the apply rules work with Icinga that you don't need to sort of explicitly have a service. You can just simply match a pattern or a role or a device type and then have that flow through to what monitoring gets done on that particular device. That's why we called this server mail server with a lowercase m, and we went from there. So that is the Netbox stuff. Did you want to add something?
Can we put the download link, like just open it in the terminal or some text editor, just put it in the corner there somewhere?
Has everyone actually got the download link? No? You what? You tweeted it. Awesome. You are authorized to use this on social media. How do I make this stupid thing work? Ah, that's not going to work.
Just grab that.
I'll just close my entire presentation then. Oops. Then I'll make this a bit smaller.
Yeah, exactly.
All right, so as long as everyone's got the characters, we should be okay. As for, I need to have two things, a bit short on screen real estate. So Netbox can deal with a whole lot of different stuff. We've gone through probably the most important things for getting a server up and running, because we already had some racks. What else do we need to cover with Netbox? Yes, we do want to do that. That's important. Or we don't have to do that. We can just add an interface, because that's important, because we can't really monitor things. So we can call the interface etho. It's a 1 gig NIC. Management only. We can use that if we need to or not. That's pretty useful. And then from here we can add an IP address to etho. I'll make this 10. Actually, I'll make it 8.8.8.8 just to be interesting. Every IP address in Netbox has to have a net mask. It uses that to check for IP address conflicts. So you can have a new IP or an assigned IP at this point. For customers, did anyone got customers where they've got the same IP range in two different sites and they've got overlaps? So that's where we use VRFs for that. So in our case, for our internal use, we've got lots of customers with overlapping subnets because we have no control over them. But we still want to be able to enter them in here and monitor them and things like that. So what we'll do is just simply have a customer or a client per VRF. And then that way you can pick a VRF and that will give you let you overlap the IP ranges. Pretty handy. DNS name and tenants are the same sort of thing. You can have tenant groups and tenants. That's useful in racks where you've got, for example, provider gear. So the tenant can be Telstra and they can own that particular gear, and then you can use that for support information if needs be, or however you want that, just to keep track of what's going on. Importantly, I think we have to use the primary IP. We have to tick this primary IP for the importer to work nicely, and it supports NAT as well if you want to keep track of NAT rules for IPs. So now we have a server with an address. Netbox also now in the most recent version supports cables. So you can actually connect a interface to a switch port. You can have an A side and a B side. I don't have another rack, but I can pick, you know, a different device. Haven't set any devices up in that rack yet, but I can plug, you know, Etho on this machine into port 24 on that switch and record the cable type. And we've worked with them on fleshing out some of this. The cable label and cable numbering is something that a lot of our customers use because they've got structured cabling, so every cable has a number. They have tens of thousands of them. And so this part of Netbox is going to be expanded quite significantly to deal with structured cabling and numbering and generating a new number. And we've even started to do a bit of work on being able to print cable labels with the right numbers and the endpoints and all those kind of things. But printing is a pain in the bum, so I advise no one does that at all, ever. Anyway, so that's cables. We're not going to connect to anything because we don't have anything else there. And then the other thing that's probably useful is this config context. We use this quite a lot. What this does is let us, for example, take a bunch of Ansible facts and dump them as a JSON, you know, sort of dictionary or just a straight array or however we want, just a structured JSON. And then later on we can use that as useful information for the server. So that might be, for example, if the server belongs to a particular logical cluster or a group of servers, or you might want to put the SNMP community name in here if you don't care about it being a secret. You might want to put in any other useful information. Its role, if that wasn't a custom, but there are custom fields for that. So it tends to be kind of like, here's all the other stuff we know about the server that we think is important. We'll just shove it in here and then maybe come and use it later. If you have things that you use frequently from a custom field point of view, for example, you've got internal cluster structure and you want to be able to say this is a Kubernetes server, or this is our web server front ends, or these are our proxies, then you can have custom fields and have roles and other things, or you could use device types for that as well. So there are a few different ways you can mix and match the grouping of machines. And virtualization lets you do a similar thing where you have a cluster, that cluster has physical members, and then the virtual machines belong to that cluster. You pretty much have to have a cluster if you want virtual machines to work. It doesn't let you just have a random virtual machine. So even if the cluster just has one physical member, you still need that. So circuits and power, pretty obvious sort of things. And that is pretty much our Netbox tour. Before we go any further, any questions about Netbox? Impressions? Yes?
So a very probably inappropriate question. Is there any way you could get your Amazon stuff in here as well?
Yeah.
Just specifically for our physical stuff?
You can definitely get your Amazon things in here. So virtualization, I think it might even actually have cluster types of public cloud in here already.
Just it would be useful to have it all in one.
Yeah, absolutely, and yeah, I'm not suggesting you shouldn't have that at all. So already has, this is like the blank Netbox with the default imported data. So the default Netbox imports Amazon EC2. And then the useful thing for that is I can click on it and see what hosts belong in my EC2 as a cluster. I can add a device in here, which I don't have devices yet, but or I can add a virtual machine to a cluster. So let's go ahead and do that just to sort of make things nice and clear. Stu's crappy EC2 box. You said it was inappropriate. No, that's not in that cluster. We want to be able to, I don't think we actually have a cluster in EC2 yet. So this is one of those things with the data model where you're like, oh, I went to add something, now I can't do that because I actually have to have a cluster in here. Oh no, that should have worked. Public cloud, EC2. It should have already known that that was there. Oh, select, add device. That's a device. Maybe you have to add a device for a public cloud. We'll give that a go. EC2. Obviously, with cloud things, it gets a fair bit more complicated. I'd recommend you have a type of thing called EC2 instance, and probably its manufacturer would technically be Amazon, and its device type would be the size of device it was. It would make some sense. But for now, we'll just pretend that it's an HP DL380. And then I think we can put it, let's see, why has it got Not got Amazon in there. I'm not sure how that works, but we'll see how we go. How we go. Oops. So I did something wrong. Oh, it's in the wrong. There's no site. You'd put in a data center, which would be your region, I imagine, as a place that it lives. I don't know where 2016 came from. Virtualization, virtual machines. We don't have those. When I've done VC2 before, like vSphere, and I've done it with VMware. I haven't done it with EC2. I haven't even attempted. You can fiddle with it. You'll have a VM that you can play with. We can add that device there. So it's not super useful from that point of view. Yeah, I mean, this is meant to be for data centers. I think it's useful to have EC2 in there, particularly if it's part of the monitoring infrastructure and all those kind of things. And obviously people have a mixture of, their own hosting and public cloud almost always these days, in my experience. So good question. Anything else for Netbox? Yes.
You said before, and I agree with you, that Netbox should be clean. It should be your authoritative source if you can use it, and you probably shouldn't have discovery feeding into Netbox. Have you got any suggestions for how you cater for tenants in a data center that might just like to randomly install stuff and not tell you? And so you could find a disparity where this rack says it has nothing, but actually we're seeing stuff for it.
Yeah, we're actually about to tackle that with a customer of ours because they have that exact problem. They have sort of racks around the world, and so we will be doing, to some extent, you could cover that with monitoring. Because if they appear on your network and they're not in the documentation, to me that's actually a monitoring problem, and we could actually make a pretty simple plugin that compared, that's a check command, that's a new plugin for Icinga that says, right, here is the Netbox rack details, here are the things I found on this subnet, there's extra stuff here, and then throw a critical alert and say the documentation's not correct. That's thinking on my feet. I haven't done that yet.
Also, another way you can do it, if it does get into Netbox, if you do have some automatic import, we ran into this earlier.
Yeah.
For example, like if you've got things that have duplicate IP addresses, and you say, I want to assign, this device, and I want to say the primary IP address is, 192.168.1.1. You've got another thing in there, inventory management thing that says, oh, my primary address is also 192.168.1.1. They don't have validation on their side. It goes into Netbox anyway. You can run these things called, go to organization, go to reports. So what you can do is you can write these kind of little Python scripts that import the some Netbox kind of classes and stuff like that, and we haven't got one here, but you can run a report, or you can run a report via the API, so you can just have it triggered on a cron job or whatever, and it'll say, hey, I found these things and this data doesn't make sense. You can write your own custom logic depending on the types of problems you have.
Yeah, we're doing a lot of work. The really big site I'm talking about, they've got on-site inventory on each of their 550 sites, and the people that have been installing the gear there have been updating the on-site inventory, and they spelt Aruba like 8 different ways, that kind of thing. I don't know how you managed to do that, but so that's just one of the problems. There's just heaps of messy data. So data cleansing is a big problem, but you're kind of better off to some extent automating putting it in and automating and taking it out, and then kind of figuring out what's wrong and then doing it again. So there's no substitute for toil with some of these things, unfortunately. The reason why this makes a lot more sense than a spreadsheet or a wiki is because it's structured in a way that is useful. And that's, to me, the big revelation of Netbox. And I encourage everyone to sort of hack on it from an open source point of view. The GitHub is very active. They're happy to take bug reports and patches and all those kind of things. So it's very much an open source thing. If you're interested, I'm sure you can figure out where to find it. Alrighty, we'll move on if there's no other questions. Lost my slides completely. Do we want to do a Icinga walkthrough? So we've set up on your VM. Has anyone got the actual VM yet? Quick lab check. You have got it? Did it work?
No, I was just looking at the network settings.
Oh, okay. Okay, cool. It should be like host-only NAT thing. It's weird with VirtualBox. You don't get a LAN on your own machine that you can bridge it to. It's all user space. So the settings that came with the OVA should work for VirtualBox. I can also give you a copy of the actual VirtualBox machine if required as well. Anyway, so Icinga is like Nagios in the sense that it doesn't know what it's doing. It runs a plugin, gets back a return code, and then updates the users or the web interface. We've added some things using Director. Anyone not familiar with this stuff? Anyone first time seen this? First time users? Cool. You guys used Nagios before? You know how that roughly works? Cool. All right, so the key point about this, and there is some debate in the sort of monitoring community about the idea of metrics versus monitoring. And we're very much, from a primary point of view, on the sort of monitoring point of view. What we do here is define criteria for a check to be okay, and they're either okay, warning, critical, or unknown. And because we've put some random dummy data in here, you can see each of those states represented. Unknown being, I asked the question, I wasn't sure what the answer was, I couldn't connect and actually get the information, I'm going purple. Warning being, I've reached the warning threshold that you said, and critical being, I've passed that. So they have hard and soft states. Icinga represents sort of 20 years of monitoring engineering, so it does all those things very sophisticated. One of the most important things that it does is that it's clustered, so it can be master-master and scalable. You can have a node at each site, if you've got a Linux box there or a Raspberry Pi, and it can scale out to a very large scale. So our 100,000 hosts work just fine because while you see 100,000 in this web interface, all the checks are getting executed on 500 and something hosts around the world. So the actual load for pinging things or getting back SNMP data is on those, and the status just gets passed back to the single thing. Another data point, and this is kind of a bit of a interesting one. I've got an instance that monitors all the pubs in the country, and to see if they're online or not. And so it's like 35,000 checks that it's executing. It does it in 4 gig of RAM with 2 CPUs. So it's quite lightweight from that point of view, and that's just one instance. That's not a multi-node cluster. The key with that is, though, that some of those checks only execute like once every few days. So we don't care if the pub's offline straight away. We just care if it's sort of stopped working for a little while. And so the check frequency is the most important thing from a scaling point of view. In this instance, we've added these things using Director. So the install, and on the virtual machine, actually, by the way, the install, we've used Ansible to install Grafana, InfluxDB, and Netbox. So you can follow along. The install for this was done using just following the documentation. Super default, all the passwords are in a file called passwords in the /root directory. You'll find that. And so this is a basic install. There's a single zone called master, and all of this stuff has been added using Director. So I'll click through these things. Firstly, we've got a host. A host has services. And that service, the graph isn't loading, Ollie, but we can fiddle with that. We can use Grafana for that. So there's an add-in for this web interface which embeds Grafana graphs, and I don't know if it never worked. We had to zip up and start uploading this VM, so we can fiddle with that later. And then if you've got services, a service can have history, and I find this very useful. For example, I repatched one of my servers a couple of weeks ago, and now every day at midnight, 12:01, it goes off for 30 seconds. And so I saw the alert last night, and I was like, oh, I wonder if that's been happening. And you can see a very clear, it's been okay for months, and then every day after midnight, it just goes off. Just one little blip, like not enough to actually trigger an alert, but just enough to kind of track what's going on. So history is super handy for diagnosing those little annoying problems. And then, so this is the rough overview of the web interface. We've got a tactical overview down here that we use reasonably often, and divided by host services, host groups. You can map host groups to, well, we have mapped host groups to sites. Nice work. Just in time. And then service groups are obviously useful for, if you had lots of different mail servers or web servers or whatever else you need to monitor. So this web interface has a series of plugins. And then Director is an add-on. It's upstream supported. We provide commercial support for this, by the way, but the upstream guys, Netways, they're kind of like our German cousins. They're the ones who forked this and have people that work on Icinga full time. Director is a first-class citizen, and they provide support for that as well. And Director is really a sort of ETL tool for how you manage the sort of import of hosts. Now, there's nothing stopping you editing command line files, and the documentation, the official doc will walk you through all that quite well. It has a domain-specific language, so you can do quite powerful editing, which you couldn't do with Nagios, for example. You ended up repeating yourself a lot and having a big sort of spaghetti mess. Whereas with Icinga, you can simply define custom variables for each host, and then have that host get checks applied to it based on those variables using a series of apply rules. So for example, I have a host that has the word mail in the title, or it has a custom variable called I'm part of this cluster, and then you have a definition that says apply this service check of SMTP to all the hosts that have the word mail in them. We can go through that in some detail if required. We've abstracted away all that into a sort of this web interface, and we'll walk through how that all works. Do you want to take over, Ollie, and have a crack at what we've done here with Director?
What about the automatic import or before that?
Yeah, just a basic host first, and then add a host and do some Director stuff.
So like I said, we'll add a host to a sync, and then we'll do that.
Yeah, sure, we can do that. Do you want me to run it, or
Yeah.
you run it?
Okay, yeah, sure. All right, so I guess what I'll do is, why don't we just go back to Netbox?
Do you want this?
Yeah, sure. All right, thanks.
credentials to log into all the things somewhere?
We probably didn't put SSH credentials in there because they're on the machine itself.
Yeah, like in Icinga, for example,
If you SSH into the machine, you can, but the username's
Or of the console. Oh, yeah, but the
DAING
username.
and the password's
Yeah,
DAING
do you
lab.
want to put it on a? Let's put it in a.
Sorry.
Can I move it like this?
Yeah, we can do that.
So I think password for a lot of these is unman. Oh yeah, okay. I need yours.
Everyone get into the box. Who's got it? Yeah.
Take off your lanyard or it'll
Oh no, it's okay. Thanks, man.
Let's have a break.
Yeah.
How are we doing for time?
Yeah, good question. So 11:18. What time does it stop? Bloody hell. All right.
Perfect.
Cool. Okay, so for people who do have the VM up and running, to get into a lot of the web interfaces, it's the username is admin and password's danglab. If the password's not danglab, it's probably just admin. Yeah. So we've got Icinga, which is kind of cool, because we have all these hosts and monitoring all this stuff. But it's a pain to have to manage like both Netbox and your Icinga or monitoring configuration. So often I've been in companies where you have this inventory management system in like a MySQL database or in a bunch of spreadsheets. They add to that. They send you a ticket and say, oh hey Ollie, can you add some monitoring for this thing? So okay, so I look at their thing. With Netbox and Icinga, what's nice is that we've got this automatic importer using Director. So the idea is that where's Netbox in here? Yeah. So all the stuff in Netbox, we have these 4 servers. So if somebody goes along and plugs in a new server or they make a new VM or whatever, we run a magic sync and we should see, let's take for example mail01 magically appears in here and it's monitored, it has some SMTP checks and it even has some metrics from the SMTP plugin. So how does that work? So what you do is we use this thing called Icinga Director, which manages a sync, as Dave was saying, from arbitrary data sources into Icinga. So what the import sources do is they take some data, let's say from an HTTP API or a MySQL database, and it'll put all of the properties into its own database, and you can do some data transformation to make them, convert them into Icinga objects. So objects are things like hosts, services, host groups. So we've got a couple of sync rules here that you can run on a schedule. For example, that's the simplest way of doing it. So we've got here a sync rule called devices to hosts. So we're slurping all the devices out of Netbox and making host objects out of them. So we get all the devices, these guys, and make, where's that Icinga web? Here, and we make host objects out of them. Oh, we've added some hosts, so. Yeah, so same thing for host groups. So if I look at the host groups, what we do is we map the sites from Netbox, and we make host groups out of them. And of course, all the devices that belong to a particular site are in there. So we've got Mail1 in Equinix is in the host group there. So what I thought would be cool is let's just do a demo of it just to kind of run through the thing and also check if everything's working. So let's add another, let's say if we had another mail server. I was actually going to add, does anybody have some public mail server that they know of, about like smtp.fastmail.com or something? Does that work?
Yeah, I think that works.
Yeah.
That's still FM, isn't it?
Let's see. Yeah, I thought of Fastmail because you were sitting there. Yeah, what have we got? Oh, you're in one.msng. Yeah, okay, that's good. All right, so let's imagine that we've added a new thing here. So we'll go, let's just call it mail2. The device role, let's just call it a server for now. Oops, your touchpad's weird, Dave. Let's imagine that their SMTP server is a HTTP DL380.
Site.
Yeah, whereabouts is that?
Down. Stop.
Still more?
Up. Stop.
Oh, there, okay. Of course, they host it in Melbourne because they're in Melbourne. Okay, so I've got a device. Let's add a interface to it.
You can actually have a template for a device, so the device automatically, that type gets populated with the right amount of interfaces. 4 NICs or 24 ports or whatever it might be.
Yeah. MAC address, no, not needed. Okay, so next I'm going to make an IP address. So let's do host of this guy.
Middle thing will paste if you just want.
Yeah, it does, nice. Okay, let's just use one of these. Use that. Yeah, thanks. Guess that's it. Yeah. Blah, blah, blah. So now if I go back to my new mail server, I've got an interface. So what I want to do is assign an IP address to the interface. Ooh, what was it? 7066. Okay. Okay. And then the other thing I do want to do actually is make it the primary.
You have to go down to edit the interface. Edit the IP.
Hmm?
Oh, yeah, you can do that.
Oh. All right. So now I've got a second mail server hosted in Melbourne in Equinix. It's an HP, and it's only got one interface, and it's got this IP address. So that's cool. So I've just added that. So now what I can do is go back into Icinga and say, okay, I want to monitor this, this new thing. So we're going to do it manually for now. What I do is I do this big database slurp to put it into its database. And it fails, of course, because, there is no address. Oh, yeah, because I've got a hard fail in there. Can we delete that device that we made before?
Yeah, you can delete whatever.
Yeah, okay, well, this is an interesting thing to talk about. So, for example, like if they don't set something up correctly in the other inventory management, you can set Icinga to fail on things. So, for example, it's not going to import a device that doesn't have an IP address because it can't monitor that, right? So you can have a bunch of rules that say, okay, don't import it if the host name matches this particular regular expression, for example.
What else could you do? Other examples? I'm just trying to think.
It's a pre-cleaner on the import process, so you can
Yeah.
have a stab at actually having useful information.
Yeah, yeah.
Because, for example, Volkswagen use the Excel importer to do the Excel. They funded the development of it, and I'm sure they've got all sorts of random crap in their importer. So that's a useful feature for that.
Okay. So we run that. Now we run a sync rule. I want to add in a bunch of new hosts. So I'll just do this and see. So it actually kind of shows you sometimes. So if if you change the IP address, this is an interesting thing. We'll do this later. But if you change certain properties, let's say, for example, we've got that new mail server. We change the IP address. It knows to update the address in the monitoring. So we run our sync. Director has this change management stuff. So for example, if all this does happen and things get added, things get monitored, you can easily roll back stuff. So how that would happen for whatever reason. Particularly if you're sending out alerts, that sort of thing. If you add a bunch of hosts that aren't correct, you can just quickly roll back and save having to get people out of bed. Yeah. All right, so let's see if it worked. So I guess, yep, there we go. So all I've done is I've just added a server called Mail02, and it's added this thing in here, and it's also been magically assigned an SMTP check as well. So that's handy. That's good. So apparently Fastmail's MX is up and running. That's good. Lucky.
It's not great.
Yeah.
Not so fast, actually.
Yeah, well, no, that's weird. No, it's the same for the LCA one. It was like 6.5 seconds or something, which is, yeah, but it's not anymore. Yeah, so.
How did that work? Why did we get a check? How did that work?
How did that?
Apply rule.
Oh, yeah, good thinking. All right, so all I've done is, in the old Nagios days, you'd have a bunch of services and you'd have to match each one to each host that you were interested in. But in Icinga, what they've done is because of the DSL that they've done, and they've allow you to use quite a fair bit of the DSL in the web interface. So I've made a service apply rule called SMTP, and you can see the SMTP service is applied to, let's say, where the host name matches this wildcardy expression thing. So that can be handy. But you can access all sorts of different, let's say, attributes in different ways. You could say, I want to assign this where the host group is in Equinix, but is not in the host group, FTP servers or whatever. So you can build these kind of bits of logic up, and it saves you having to, as I said, manually assign things and kind of keeping it all in your head. You can just have the rules there defined for you, and you can keep this stuff in version control or whatever. Yeah, so yeah, I guess that's that. Now, the other thing that's nice is with Icinga, they have, I think it was a few years ago now, actually, a long time. Anyway, so with Nagios and also with Icinga, you could have performance data. So how that works is that for each check that runs, you can optionally kind of give back not just the OK or the warning or the critical status. You can actually give back some things telling you really how it's doing. So for this particular SMTP check, we know that, okay, it's taken 2.5 seconds to do just a quick check. That's cool. We can see that there. It gives us a bit of context. But what's nice and what managers and stuff really like is if there's pretty graphs everywhere of this stuff. So how this works now is, you can write, they've got like a little plugin, and so any performance data that Icinga receives, it'll write that to an InfluxDB database. And once it's in InfluxDB, that's cool, because you can, InfluxDB, there's a bunch of nice front ends to that. The one that we use a lot is Grafana. And so, oh no, what happened to the dashboard? Recently viewed. Oh, here it is. No, it's right, it's here. Cool, all right. So, we did this a little, I guess, yeah, this is when we got the VM kind of sort of working. Was it 951? Yeah, so that's interesting. So the green is for our, that's actually mail 01 is our, I guess, LCA on linux.org.au's mail server, SMTP, their one MX record mail server. And the other one we've just added is, that was fastmail's one there. So because we've added it to Icinga, and because the checks are being run against those servers, Ichinga's writing to InfluxDB, and we have this nice dashboard, and it kind of just magically works. So yeah, you can see, you know, however long things take. Yeah, I guess.
All right, that about covers it.
Yeah. Oh,
So,
no, actually, yeah, oh no, one more thing is also just the way Director works is if you delete something, this is a big thing, right? If you delete something, it also gets removed. So that's kind of often with these import things, you don't get that sort of functionality, but Director handles that for you. So if something gets removed from Netbox, it'll delete it, and yeah, works quite well.
Yeah, excellent.
That's it, yeah.
Thanks, Ollie. All right, so is this microphone working? Doesn't sound as that one.
Do you want to just use this?
Cool. That's fine. All right. So we've covered off the basics of how that works. We haven't got a great Ansible demo for you today, but is everyone familiar with Ansible, roughly? If we want to go through the Ansible thing in detail, we can provide some playbooks, but the latest version of Ansible includes Netbox as a first-class citizen. There's Ansible modules that let you update Netbox, update interfaces. There are some limitations to that, so I will just pull up the Ansible modules, the official one. Where are we? I'm just going to Google that. I just wanted to point out some things here. We've got sites and devices, and for example, with the devices, you can't necessarily get all the information that you need, depending on what you've got. So there are some limitations, but most of the stuff is there. And then a sample playbook would look largely like this, where you've got a device, you connect to Netbox, you generate an API token, and then you can update that with this information. In this case, it's static data you can see in the playbook, which may suit some people. More helpfully, having dynamic facts, things like which interfaces the IP addresses are in, and all that sort of stuff is a much more sensible way of making that work. For example, creating virtual machines, and then having the Ansible discover that information and send those that virtual machine data into Netbox, and then having that, as you can see, be automatically imported, inventoried, and then monitored, and then graphed is the sort of end-to-end of this whole thing. So I wanted to cover off most of that. There was why is this not showing? There was another thing that we want to cover here with monitoring. The other thing that I wanted to point out, but just going back on the topic of Icinga, was the question that I get asked the most about what it can monitor is oh, does it do this or does it do that in terms of monitoring? I think it's important to understand that you can basically monitor anything because of the way that the plugins are structured. And then because of the way the performance data output works, you can also graph that exact same thing. So we've got customers where we've created, for example, I don't know, MS SQL queries, and we're returning the results of a query from two different servers and then using them as a check and then using that also as a graph. So we can say these two databases are working the way we expect them to, and if they don't work, then you get an alert about it, and then we go from there. So the other thing we're sort of not covering in this area is notifications and alerting. There are lots of ways you can do that. We've used OpsGenie for some people. We're currently building our own alerting platform based on Oxygen and some of the other LinkedIn tools that they've open sourced recently. I know the Catalyst guys have got another open source one called Hot Potato. And these are tools that plug in and let you define who's on call, what type of alert they'd like to receive an SMS, a push notification to an app, a phone call, all those kind of things. That's not something that is covered directly by this core stack. The notifications engine inside Icinga effectively just runs a script, and that script, for example, right now will send emails, obviously appear on the web page. You can build dashboards, custom dashboards, all those kind of things. But generally, like happens with Opsgenie, is you export all the notifications to the Opsgenie API and then have it decide who's on call and who the manager is and do escalations from there. But it's kind of expensive. There are definitely some open source alternatives and work pretty well. And there's nothing stopping you sort of rolling your own scripts with all those kind of things as well. So I think that largely covers mostly what we wanted to cover. Does that make sense? The whole end-to-end. Does everyone get a sense of how that end-to-end flow works? Would you like us to drill into any particular part in more detail? No? Do you reckon you can make use of the VM yourself, Stu? Yeah? So, I mean, let's just kind of like work through that now as a lab. Has everyone got access to this interface themselves? No? This port forward should work if you just boot the VM.
Oh, yeah, right.
Yeah. Do you want to practice adding your own host just manually? So if we go back to Director, it's one of the things that Ollie added it to Netbox and then imported it. You can also add your own gear here pretty easily. Host has a host template. So in this case, I just set up a generic HTTP only server because I wasn't sure how I was going to be able to connect to anything else as a template. So again, it's one of those things you've got to get the data model right. So before you've added a host, you need a template. Host templates are in the templates tab. I can add one. Templates can inherit from each other as well, and do a bunch of other things, and then inherit various check parameters. I note that the check parameter for the template that I had was set to a long time. It's going to take a while to do checks, but that's again a performance thing that we can use, and you can tweak that down to 1 second if you need to do. If you've got money to burn on resources and intensity there. Then the other thing that's important about the host definition is you can also have an agent. So in this case, we haven't configured clustering, but Icinga has an agent set up where you can install that on a Windows machine or a Linux machine, and they become members of the cluster. They can execute checks as endpoints and be delegated configuration and commands, and you can generate all of that through this interface. That will let you, this one is a PowerShell script or a Bash script, but there's also an API for Director itself. So for example, we've got an Ansible playbook that will connect to a machine, connect back to the Director API, enroll it in the certificate authority so that it can join the cluster, install the software, install the certificates that it's got back as part of that transaction, and then be able to receive checks and work as an agent. We kind of didn't have time to prepare all that for the demo, and it's a little bit convoluted, but that's certainly a feature and certainly works. It's quite well documented, and we use that quite a lot. It's how you will distribute checks amongst a sort of disparate geographic regions or customers or anything you want to sort of monitor from that point of view. So it's worthwhile pointing out that the agent stuff works quite well. A recent release of the PowerShell modules has recently been redone, and there's a lot of work going into monitoring Windows, and the PowerShell integration with this has been improved a lot and has still a fair bit more to go. And they also have a whole series of new PowerShell-based plugins, which will let you check files, Windows services, diskspace, all that sort of stuff in native PowerShell, whereas previously there was a sort of collection of various other scripts, some binary, some VBA, and all sorts of other random crap. So it's improved a lot, the Windows monitoring. There's a fair bit more to go. But suffice to say, we already do it for a bunch of our customers, and it works quite well. And they're quite happy with how that works out. All right, I think that probably covers most of the features I wanted to cover. This was kind of thrown together at the last minute, so unless anyone's got any things they want to work through, or if you've got a particular thing that you'd like us to solve, we're going to have some questions and then get an early mark, I reckon. Anyone else got something they want to cover off?
If you add something manually during this process, could it get trashed by the import?
No, it's a very good question. So the question is, if you add something manually here, will it get trashed during import? And the key is the host name. So you need to keep the host names unique. So sometimes we've seen various hacks to make that work where they've got overlaps of data sets or things like that. You can add a prefix to it or whatever it might be. But the key is the host name. So it doesn't care if the IP address is the same or anything like that. And that can be useful sometimes if you've got, for example, a load balancer and you want to send virtual host names, different HTTPS requests or things like that. We use this for certificate checking. And then that will let you have the same IP address but different virtual host names because some of the plugins use the host name as their argument instead of the IP address. HTTP gets a bit weird sometimes with all the load balancers and things. So no, it's pretty good like that. It will figure out, it will refuse to import if there's a duplicate, or it will know that it's already imported and update the information. So very much a synchronization process with all the caveats there.
Another stupid question. I know you talk about Ansible a lot. Do you still use declarative deployment, things like Puppet as well, or are you kind of mostly Ansible?
We don't do a lot of Puppet with our customers. We pretty much wholesale moved to Ansible once Puppet came. Once it came along. We started our configuration management journey with CF Engine, and then Puppet was invented to fix CF Engine, and then Ansible was invented to fix Puppet. So I find it much easier to train people in Ansible, and I find it much easier to have less bugs in Ansible. And that kind of goes for the amount of the staff that I've got. If I employed a team of Ruby programmers, I think Puppet would be a better choice, but I don't have that. So there's pluses and minuses to all those kind of things, but I think it's pretty inevitable. Ansible is a tool that is pretty easy to learn. You can learn in 5 minutes. You can get on with things and pick it up, and then you can take it quite a long way. So I haven't sort of run into too many limitations at this point with Ansible stuff. Yeah, any other questions? Yes?
How are you managing the deployment of your plugins across things that they run on?
That's a great question. And Ansible is the answer mostly. So, however, plugins can get quite custom quite quickly. Even for example with SNMP, you might find that the check SNMP plugin doesn't do, and we ran into this problem just I think a couple of weeks ago, where we wanted to actually get a number of interfaces. We want to be able to tag interfaces in Netbox as critical and monitor those interfaces on a switch, but not all of them. And that didn't map quite well to the way the configuration was worked out. So we wrote a shell script plugin that wrapped the things that we needed to, and then used Ansible to push that out. I advise that you use Git, obviously, to keep track of where plugins are, because you'll end up with a series of plugins that do useful things for various stuff. There's a lot of coverage with the core things at the moment. For example, just out of the box, the commands that we've got access to and that we've imported, there's some thousands of things here that cover the various plugins that are out of the box. And then this, I just picked one at random. This is Nginx status. It'll let you monitor these various metrics out of Nginx if you turn on the stats, I assume. Never use this particular plugin.
You just use the default method that Icinga uses to execute them, regards to security and agent.
Yeah, so an active check, which is initiated from the master, for example, in the case of the ones that you see here, that's the default way of doing it. We've moved away from NRPE or even check by SSH largely towards the agent method because it works a lot better. The great thing about the agent is with a DMZ and firewall rules, you can initiate the API connection in either direction. So you can have the agent installed on a machine in a DMZ, and it'll just listen and wait for a connection inbound to it, so you don't have to have it punch back home out of that DMZ if needs be. So it's really the preferred way from a security model point of view. And it's all TLS over, HTTPS over port 5665. So, and then what you'll do with that is have the configuration say that the command endpoint is the name of the agent. So when you do a service definition, that's an important sort of trick to it, which says when I apply this service, execute the command on the target machine, as opposed to just executing it here and having it ping back or whatever it might be. So, does that answer your question? Yeah, agent is preferred if you ask me. Definitely first-class citizen. Cool. No other questions? Excellent. Hopefully everyone's got a copy of that VM and they can start using it. Happy to talk to people afterwards one-on-one if they get stuck with anything in particular. And there's no kind of stupid questions there in terms of getting things up and running. Hopefully you can take that away and sort of use the config and work through it and go from there. All right, guys, I'm going to give everyone an early mark and go wrap it up. Thank you.